Understanding the Formula Sheet, Unit 10, Topic 1. First, let's focus on the names of the figures we will see on the formula sheet. The formula sheet has two sections, the 2D shapes, that is our flat polygons and circles, and the 3D solids. We will name the 2D shapes first. The most common four are the triangle from before. We can see that it has a base and a height. Next, we'll look at the circle. Two big parts of a circle are the diameter and the radius. Next, we have the rectangle that we just learned about last unit. And we have the square. That is a rectangle with 4 equal sides. The other 2D shapes on the formula sheet are the parallelogram, also from last unit, and it has two bases that are exactly the same, because remember, opposite sides are congruent. However, we also have our trapezoid, and remember that the trapezoid has two different bases. Now, we will name the 3D solids. First, we have our rectangular prism. Next, we also have another prism. This has two identical bases connected by rectangles. This solid will be named after its base shape. For example, this prism above is a triangular prism because its base is a triangle. Next, we have our cylinder, which has two circular bases. Now, we will name the 3D solids. First, we have our pyramid. Right? It has one base shape and then triangles coming off of it. Next, we have our cone, which has a circular base. And we have our sphere. Right? Think beach balls. Underneath each shape is a series of formulas that will allow you to find qualities such as area, volume, or perimeter. Here is a breakdown of what each letter in the formulas mean. The letter A stands for the area, the flat or 2D space a shape takes up. So if we have our rectangle here, filling in the inside would represent our area. Always think about painting. The letter P stands for perimeter. That is, all of the sides added together. Again with our rectangle, to find the perimeter, we would say side plus side plus side plus side. It's all 4 sides, that is, every single side in a rectangle added together. The letter H will stand for height, the length of the perpendicular line from the base of a shape to the tallest point. In a triangle, the height is going to form a 90-degree angle with the base. It goes straight up and down. Notice that it goes from the tallest point straight down to the base. And now that word base, what does that mean? Whenever you see a lowercase b, that will represent the base of a 2D shape, the bottom line of a 2D shape. So looking at our triangle example again, I can see that my base, b, is that entire length of the bottom of the shape. In our parallelogram, we can see that the base is again the entire length of the bottom line of the shape. The letter L. In 2D shapes, the letter L stands for length, the length of one side of a rectangle. Note, L will represent something else in a 3D solid. We'll talk about that later. And the letter W stands for width, the length of the other side of a rectangle. So our rectangle has two different lengths of sides. One is the width and the other is the length. And then we have the letter S. This stands for side, the length of a square's side. Because remember, in a square, all four sides have the same length. We describe that with the letter S. Going into circles, we're going to see the letter C. C stands for circumference, the length to go around a circle, like a perimeter. Also with circles, we have our letter R, and that's the radius, a line from the center to any point on the circle. So our R goes halfway across the circle. Similarly, we have that lowercase d, which stands for diameter, a line through the center of a circle with endpoints on the circle. When we look at our diameter, it's going to go all the way across through the center. There are some parts of the formula sheet that are unique to the 3D solids. Here's a breakdown of what each letter in those formulas mean. So that capital V, we've seen him quite a bit, stands for volume, the 3D space a solid takes up. Think of filling a space. How much water in a cup or air in a ball? You're filling it up. That capital letter B. So we've seen the lowercase b, which stood for base, just a straight line. When we think of the solids, that capital letter B will represent the area of a base, the area of the bottom of a 3D solid. See that capital B? That's going to represent the base of this triangular prism. So that's going to be this triangle here. And to solve for that capital letter B, we would use our triangular formula. So that capital B, the area of a base, will be found by the capital letter A in the triangle formula. Usually, we will need to solve for the base before we can solve a given problem. Let's look at LA. LA stands for lateral area, the sum of all sides of a 3D object except its base or bases. In terms of a cylinder, we're going to see that that's all the way around it, like the wrapper on a soup can, but not the top or the bottom. However, when we look at SA, the surface area, it will be the area of all the faces of a solid added together, including the base, more bases. So for our cylinder, that's going to include all the way around, the top, and the bottom. Imagine if you were wrapping a present. You wouldn't just wrap the sides. Now let's look at that lowercase l in cones and pyramids. That lowercase l stands for the term slant height. The slant height is the height of a triangular side in a solid. Let's look at the picture. So in this picture, I see that lowercase l right here slanted on the side of my pyramid. Right? Sometimes they're not going to give me that, so I'm going to need to solve. But I see that with the height and the bottom of my triangle, of my pyramid, I form a right triangle. Right? Where the vertical leg is my height, and my hypotenuse is my L, my slant height. Then I can use my Pythagorean theorem and solve for either unknown. Usually, you'll be given the height and the base, and you'll have to solve for the slant height. Now let's look at that capital B versus our lowercase b. Capital B, area of the base, describes the area, that is the 2D, of the bottom of a solid, the 3D. This will be used when solving with 3D shapes only. See how we have the base of our cylinder? The B, capital, would be the area of that circle. Lowercase b, The base describes the length, 1 dimension, of the bottom of a shape, 2 dimensions. So again, with our triangle, I can see that the base would just be that straight line at the bottom. The B would be the length of the line at the bottom.